what this is?
An engine.
A what? How do you know?
An RL-10A3 engine.
Sure. Okay, well, what's this one then?
It's a bigger engine.
Okay, it's a bigger engine.
This is incredible.
Miguel. Miguel, you're dreaming. If we go in there, we're gonna make fools of ourselves, okay? So let's just calm down and have fun and just...
Robin, look, I really need this. This is my dream. I'll never know what's gonna happen unless I try it. So let's go and find out, okay?
Okay. The things I'll let you talk me into.
Can I help you?
We're looking for information about how you become an astronaut.
Please, sit down. My name is Frank Hughes, and I'm in charge of flight training around here. What can we do for you?
I want to be an astronaut.
Mr. Hughes, he doesn't even know how to fly a plane.
I do, too.
You do not.
Yes, I do.
No, he doesn't. No, you don't.
Look,
He's a dreamer.
Well, listen, really, you don't have to fly a plane in order to be an astronaut.
What?
We have two kinds of astronauts, and the scientist astronaut doesn't have to know how to fly.
Oh.
The pilot astronaut does have to know how to fly a plane, okay? They're jet pilots, they've been to test pilot school, and so on. There's another kind of astronaut that's a scientist astronaut.
Can you tell us more about the science astronaut?
Well, sure. First of all, NASA calls those mission specialist astronauts now. And basically, those are people who have come to NASA from all kinds of broad scientific backgrounds. They could be medical doctors, they could be physicists, biologists, any number of skills. For example, Sally Ride, who is our first American female astronaut in space, is one of those mission specialist astronauts.
I was at Stanford finishing up my PhD in physics, and I happened to open the newspaper one day and see an advertisement that was submitted by NASA saying that they were looking for applicants to the astronaut program. And the moment that I saw that, I clipped it out and ran over to the office at Stanford that was in charge of that and filled out my name and sent it back in. But I really didn't think that I would get the job.
Liftoff of STS-7 and America's first woman astronaut. And the shuttle has...
This is Sally Ride's story of her first trip into space.
Roger your roll, Challenger.
The morning before launch, they take us out to the launch pad with the goal of having us strapped into the space shuttle in our seats 2 hours before the actual launch. And then from that point on, you've got about an hour and a half lying there in the chair. You're actually in orbit in 8 minutes. There's no force behind you, and you're weightless. And you can tell that, and everybody does it the first time that they get up there. You just take the pencil that you've been holding and let go of it, and it stays right where you put it. But as soon as you unstrap and just let yourself out of the seat, you just float above the seat. That's really when you know that you've made it to orbit. Weightlessness feels awkward at first, and you find that your arms and legs want to go off in different directions. They're almost floating off as if they had minds of their own. People practice doing somersaults and practice pushing from one wall to the next and practice sitting upside down on the ceiling. But once you get used to it, it's a very easy environment to live in. And it's very easy to sleep in weightlessness. You know, you really just relax all your muscles and your arms float up to about this position and your head kind of goes like that and you're asleep.
Challenger Houston. Good night, Sally.
Good night. Good night, Mrs. Calabash, wherever you are.
One thing that's kind of interesting about sleeping, though, is that, first of all, we're going around the Earth every 90 minutes, which means you see a sunrise and a sunset every 90 minutes. So day and night really doesn't have much meaning. It's very easy to fall asleep, but we would all tend to wake up maybe an hour and a half or 2 hours later, and we'd realize that it doesn't seem right to be going back to sleep. Seems like I ought to be looking out the window. Yeah, when you look out the window, the fascination is with the Earth. The Earth is a completely new view, and it's, you know, it's beautiful. Although we were disappointed to be leaving orbit, we were really looking forward to the re-entry. As the shuttle re-enters the atmosphere, it heats the atmosphere that it's going through, ionizes all the atoms, So you look out the window and all you can see is a bright orange. During that part of the reentry, you really notice your weight coming back. In fact, John Fabian was sitting next to me during reentry holding a regular camera, just a small camera. And he turned to me about halfway down and said, "This camera weighs 100 pounds." And made me hold it, and he was right. It was hard to hold up the camera.
So everything looks good on all the runways out here. It's your call. Okay, 500 feet, 230 at 8.
When you actually are in the last part of the landing, you feel very heavy. It's not hard to move, but you just feel heavy. And when you actually land and unstrap and try and stand up for the first time, you feel like you're not going to be able to stand up.
Roger, we see that. Congratulations, a great-looking landing.
When you first land, you feel almost like your head is spinning, and that lasts for probably only about 10 or 15 minutes. And your heart rate almost doubles for probably 15 minutes or a half hour, depending on the person. You know, after we got out of the shuttle and we're walking back out to the airplane to take us back to Houston, I was walking next to Rick Houck, who was the pilot on the flight, and he and I looked out over the desert, and we could see the space shuttle sitting there right where we had left it, out on the lake bed, and we both just kind of looked at each other and said, "This isn't the same. We're back on Earth." I can't believe we did that, and we both looked at each other and we both tried jumping, and came right back down to the ground. You know, whereas 2 hours earlier, if we had jumped, we would have floated right up to the ceiling and probably hit our heads on the roof. So that was the first sense that we got that, you know, it's over.
You've got weight when gravity pulls you against something, like the ground or the floor. If there's nothing to push against, you don't have any weight. In free fall, you're not pushing against anything. An orbiting spacecraft is in a constant state of falling toward the Earth. The spacecraft and everything in it are all falling at the same rate. Nothing is pushing against anything else. That's why the astronauts appear to be weightless.
Hangar 9A at the Johnson Space Center, where the astronauts do some of their training. I was looking for Sally Ride, but she didn't seem to be around. Hi. Hi.
Hi.
Is that you operating that thing?
That was me operating that arm.
Are you Sally Rye?
Yeah, I am.
Hi, I'm Robin.
Nice to meet you.
What is that?
Well, it's a 50-foot long arm that we use with the space shuttle to pull the satellites and other things that we carry up out of the payload bay and then leave them in orbit.
How come you don't just go outside and do what you have to do?
If you're going to go outside, you've got to put on a spacesuit, get pressurized, open the airlock, and it takes a long time, and this is very easy.
So how's the gravity level out in space?
Well, of course, gravity is always there. In fact, that's what's making the space shuttle go around the Earth, is the gravity of the Earth.
That's pulling it towards the Earth?
That's right. It's pulling us towards the Earth, but we're going so fast in that direction that we're almost falling over the side of the Earth. It's just like being in an elevator. If somebody were to cut the cord on the elevator, okay, and you were at the top floor,
You would fall.
you and the elevator would fall at the same speed. And you could say that in the elevator you were weightless. In fact, if you were standing on a scale that was measuring your weight in the elevator when somebody cut that cord, as soon as the elevator started to fall, you'd be reading 0 weight. You just float right up off the floor of the elevator.
Is it possible for you to show me how you operate that arm?
Yeah, sure. Right now, what we're using is TV monitors. This is a TV camera that's right on the end of the arm, so it's looking right at what the arm is looking at.
So you can see what you're doing.
See what we're doing, and we can also see right out the windows what we're doing. But we're trying to line up this target that's on the satellite and put the arm right over its probe.
Ooh, it moves fast. I can move it forward and down. Ooh, look, this is fun.
Okay, that's probably far enough.
Good. Oops.
So what we're going to do now is move the arm down over the probe that's on the satellite. And all I need to do that is to push in on this, and you can see this picture getting bigger, which means the arm is moving down over the grapple fixture.
And what's the grapple fixture?
The grapple fixture really is just a fancy name for a probe.
Okay.
We've got to put the very end of the arm, the can, over that stick, and then we'll close around it, and that's how we hold the arm close to the payload.
Sally practiced with the arm for 3 years before she used it in space.
Okay, right now the arm is attached to the satellite. And so just by moving the arm, I'm going to try and pull the satellite up out of the payload bay.
What you're lifting right now, is it weightless?
Up in space it would be. Down here on the ground, we use a helium-filled balloon.
If you fill it with helium, then how come it just doesn't float up in the air and keep going?
In space, it would be weightless. On the ground, it's what we call neutrally buoyant, which basically means that we've taken a balloon and filled it with helium, so it really wants to rise, just like any balloon that you fill with helium. But it's really got some weight, and the net result is that it'll stay where you put it.
So it kind of floats.
Kind of floats.
So that's neutrally buoyant.
That's neutrally buoyant.
Okay.
Well, Mr. Hughes, how do you get picked to be either kind of astronaut, either a scientist or a pilot?
The way you get selected is a very long process. First of all, you have to have the qualifications. You have to be one of those jet pilot types, or you have to have a high degree in some physical science. One thing to remember is that it's difficult to become an astronaut. For example, this year about 5,000 people have applied, and only 12 will get selected as astronauts.
What can we do now that we're still in high school to prepare ourselves?
You know, so that in 10 or 15 years, we'll be ready.
If you are in high school now, or especially in junior high, taking any kind of science classes that you can get a hold of, okay? Joining science fairs or science clubs, things like that, where you can learn about your world, okay? Learn how to investigate, learn how to think like a scientist, and begin to prepare yourself. It's the way to maximize your chances. Now, on the other side, you have the route to go be a pilot, okay? Anybody coming up through the ranks, if you get a college degree, and if you have the skills, you can become a pilot.
I was always small. I was smaller than every other boy in the school and smaller than most of the girls. So I never really fooled myself that I was going to be a professional athlete. I thought I might even want to be a garbage man. I just thought it was fascinating to see guys work the garbage truck. There were times that I wanted to be a scientist, times I wanted to be an engineer. Of all the things I'd ever thought I wanted to be as I was growing up, there were two things that I didn't even consider. I didn't want to be a Marine because I thought all Marines were crazy, and I did not want to fly airplanes. I was in Patuxent River, Maryland when I got a phone call saying that I had been selected to come to the astronaut program. What I immediately want to do is fly the space shuttle, right now. At the end of my first 3.5 years at the Naval Academy, I started thinking a little bit more seriously about what I wanted to do.
Charlie graduated from the U.S. Naval Academy with a degree in electrical science and has a Master of Science degree from the University of Southern California.
I always really like science. I always like asking why, or how did that happen. I look at everything as either being art or science. Art being the fine things, just being able to appreciate something without understanding what made it or why it's there or anything. And science, in my mind, is on the other side of the coin. You may see something and appreciate its beauty, but you want to know where it came from, why it's so beautiful, you know, how it all came about. Okay, we're within 2 minutes of the burn, so I can take the science side of it and listen to somebody talk about how it came into being or how they made it. And I can just eat that up all day. 2, 1, burn's complete. I grew up in South Carolina, and I was a typical boy, I think. I always liked to go out and turn over rocks and look for snakes and stuff like that. Everything that my mother and dad had told me not to do, just like my son does nowadays. You better slow down. Huh? I think the way that I got into the program out of 5,000 or however many applied was just be in the right place at the right time as much as anything else. That's the biggest thing to try to get a kid to understand. He or she looks at us when we come out as an astronaut, and you know, you can see the stars in their eyes, and they're telling themselves they can never do that. And that's just not true. Anybody on the face of the earth can do exactly what I've done if they apply themselves and if they can get as much out of school as they can and decide that that's what they want to do. It takes some luck, but you've got to be prepared. Then your chances of being lucky go up astronomically.
Tower, that's a 909, take off 1 VFR, be asking for close pattern.
909, wind 180 at 8, clear for takeoff, close to
909. Okay, 3033, and we're getting ready to start engines, and we'll be VFR in the pattern for about half an hour. Everything looks good, so I'll release the brakes. We're now in maximum power, we're rolling. It's like somebody kicked the airplane all of a sudden because you're kind of pushed back in your seat. We're passing 120 miles an hour. Just pull back on the stick and we're airborne. Landing gear's coming up. And the flaps are coming up. It's really pretty up here today. There's not a cloud in the sky, so it's one of these kind of an aviator's dream days. They can look all the way up into Houston and beyond it, so it's great.
When you talk about flying, there are times that it's a very special experience when you can turn it upside down, do acrobatics and stuff, and just kind of hang in the straps or push forward on the stick and make yourself float up out of the seat. That's a lot of fun, and I think that's half of the thing about being down here. I think that everybody, a lot of us, especially the aviators, came down here for was to have fun, to keep having fun, you know, because we're still little kids, I think.
Space camp, where astronauts like me train for a simulated shuttle mission. Space Camp, Day 4. Shuttle Mission Day. After 3 days, training complete.
Erica, I want you to be the commander for this mission. We're going to have a couple of problems on the mission, and if the team does not get the problem right, Erica is not responsible. The team is responsible. That is the most important thing that we can teach you here, that it is a team effort. Now, David, you're mission director. You're the head man on the ground.
What am I?
All right, you will be also a mission specialist. You'll be making sure everybody stays alive up there.
Our crew is finally ready to board the shuttle simulator.
You are cleared for launch at T-minus 50 seconds and counting.
Roger, APU power at maximum. Gimbal checks main engines completed at T-minus 25 seconds.
All systems green. Main power to launch systems on.
Launch, T-minus 12 seconds.
8, 7, 6. We have main engines.
Clearing the path. Liftoff. We have liftoff.
Once we're in orbit, Rebecca, Andy, and I come through the hatch into the Space Lab. The Space Lab crew works together to perform a series of experiments. We have headsets so we can talk to Erica, our commander, and to mission control back on Earth. We work through scripts, just like astronauts do when they train for a mission. Every mission at Space Camp has a surprise problem. But we've learned that if the team works together, we should be able to solve the problem, whatever it might be.
Mission Specialist, the lights back here in the space lab are just starting flashing on and off.
Commander, our lights are flashing off and on back here in the Space Lab.
Houston, we have a problem with the lights in the space lab. They've started flashing off and on by themselves.
Check your light switch and be sure it is flipped up all the way.
Is everyone feeling okay?
Negative. I'm feeling a little lightheaded right now.
Keep me advised of your condition.
Commander, are your avionics functioning okay?
They're all okay.
It smells like something is burning. And then turn down the fire.
Our problem is to decide how to put the fire out safely. We have to take the right steps, in the right order, that is.
Okay, I say.
What? C.
Also, if anything goes wrong, we'll have our emergency oxygen masks on.
Okay, so who thinks D could work?
The right answer is to turn off the electricity, then put on our oxygen masks, turn off the pressurization, and use a fire extinguisher.
Does everybody agree on C?
Aye.
No objections?
No.
We got it right. No problem. Space Camp. Final entry. I had a great time here. When it's my turn to go on a real space flight, I'll be ready.
All sea creatures have movements in their own unique way. They adapt to their motion to stay alive another day. Some do something that's different, like the rockets in space. They shoot the water behind them and jet forward to a new place. It's propulsion, propulsion, like the rockets in air. It's propulsion, propulsion, and it stays on taxi fare. Jet propulsion is handy if you're in a tight place. Action leads to reaction, just like the rockets leaving for space. Rockets, 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 leaving for space.
In 10 to 15 years from now, if we apply to be astronauts, what will be happening?
Well, the only thing I can guarantee, it'll be very different than it is today. For example, shuttle by that time will be kind of an old spacecraft, and it's very likely that we'll have a second-generation shuttle, maybe son of shuttle. We know we're going to have a space station, and that's going to be a big deal because now we're not going to talk about just two kinds of astronauts anymore, but they're going to have to be technicians to take care of the station, people to help put big chunks of metal together, things like that, okay? So we're looking at a whole new generation of types of people who will be there. I think that you might see us, as the United States, going back to the moon. There could be mining enterprises on the moon.
Wow.
Ultimately, you're going to look at going out to the asteroid belt or places like that. We need certain kinds of metals here on the Earth, and there are not enough of them around, so we're going to have to go somewhere else to get them. It's not impossible to think we'll go to Mars. That would be fun.
Yeah.
It would be just about the time when you're ready to go to work for us.
So we'll be able to go a lot farther than we can even dream now.
I don't think you could ever dream how far we'll go.
The Broadheimer Gang will return next week with another mystery.
321 Contact is a production of the Children's Television Workshop.